Now let us learn about the ARIS recovery algorithm. ARIS recovery algorithm helps to recover the database by using VAL protocol and by using the combination of redo and undo operations. Now let us see where is the place where it will redo the operations. In order to understand when the system crash and what are the transactions that executed before the system crash and those transactions which were actually committed. So the ARIS algorithm will catch upon all those transactions that occurred before the system crash and they were committed. So it will redo them all in order to reconstruct the database. Now let us see how it uses undo. Now it makes sure that the undo process is not repeated again and again. Okay. Why? Because the transactions, if of a transaction which occurred before the system crash and it was not committed, it means the transaction was in the middle of its execution and it crashed. So in this case, the ARIS have to undo the changes this transaction made to the database to get the system back, to get the database back into the consistent state. Now, while doing this undo, it makes sure that it undoes only one time. It will undo the transaction only one time because it is not needed to undo the transaction which is already undone to save the time. So it's like it will ensure that ARIS doesn't need to re-execute the undo operations that have already been completed. Now here, only 3 points you have to understand. The first point is that it is going to use VAL protocol. Okay, so you need to quickly revise the concept of VAL. We write ahead of making the changes. For example, if the transaction T2 wants to make changes into the data item A, it will record the changes first before making that change actually done. For example, if I want to take a class tomorrow, I have to inform you first before I actually take the class. So this is writing ahead. Now, the second thing is that we have to understand how does ARIS use redo to reconstruct the database from the crash. It will see that all the transactions, it will analyze that what are all the transactions that executed and reached its completion and they committed. And then the system crash happened after they committed. So it will use that log and it will redo all those transactions because it knows that these are the safe transactions that run and they committed. Okay, so it will redo them all. Now let us understand how the ARIS uses undo transactions. It will first of all ensure that the transactions that executed before the crash, okay, are not committed. Okay, so all the, you can say it like this, all the transactions that occurred before the crash and they were not committed are undone. And once you undo one transaction, there is no need to again undo the transaction. So this is the rule of ARIS recovery algorithm. Let's proceed. Now we have a simple example here. Suppose that we have an employee table whose structure is like this. We have employee ID and we have name and salary. So the transaction T2 and T1 are operating on this table. Now let us see the transaction T2 is trying to update the salary of the employee whose ID is 101 to 60,000. Okay, so transaction T1 is trying to make a change into an employee whose ID is 101 to 60,000. The transaction 2 in the same time is trying to insert a new employee with the ID 102, name Alice and salary as 55,000. So T1 has to do one job, T2 have to do another job. Now let us see the sequence of events that can create a system crash. First thing, T1 starts, okay, operating on this data item and modifies the employee 101 salary, but it did not commit yet. It means it is in the middle of its execution. It did not reach its completion and hence it did not commit. So if you see the T1 is going to be incomplete, okay? So it's incomplete. It did the work, but it did not commit. It is same as if like you have finished your homework, your assignment, but you did not send it to the teacher so that she can grade you. So T1 have made the changes to the table, but did not commit. Now T2 starts working and then T2 starts execution and then insert an employee 102 and commit successfully. So now if the system crash, which transaction you think will be redone and which transaction you think will be undone? Yes, T1 will be undone because it was not committed. T2 will be redone. T1 will be undone. Sorry, T1 will be undone because it is not committed. T2 will be redone because it was successfully committed. So now T1 crashes before it can commit. Now let's see how Aries would recover the database from the crash. Now let us see how. Okay, this is from our knowledge. I mean, from our common sense, we are saying that because T1 did not commit, okay, we have to undo. And T2, because it committed successfully, it means there was no problem in this transaction. So we are going to redo. Now let us see how the Aries thinks about the situation. We are here analyzing based on, some logic. Now let us see how does this logic is seen by the Aries algorithm. It will analyze first. It will analyze the situation. During the analysis phase, what does it do? It identifies that T1 was active but had not yet committed. It also identifies that the insertion of employee 102 by T2 was successfully committed. So now it understood the whole story. T1 was active, not committed. T2 finished the work and committed successfully. Analysis is done. Now it will decide what transaction to go backward, what transaction should go forward. So we say undoing phase. First it undoes the T1. How Aries perform the backward pass, it is called as backward. Up till now in the chapter we were saying undoing, right, and rollback. Now we have another term that is used basically in the Aries algorithm for conveying that a transaction will be undone. Okay, so Aries performed the backward pass and undoes the changes made by the uncommitted transaction. In our case, it was T1. It reverts the salary of the employee back to its original value. Okay, so the changes, what it did, has to be now removed because it did not commit. The redo phase is like going forward. So Aries goes through the log, okay, and because see, wherever you make a commit, it means the transaction log is updated, right? So Aries goes through the log and find out that T2 completed successfully. So it looks at the committed transaction list and it finds T2. So it will redo the T2, which inserts a new employee into the database. So are you understanding what did we do in the analysis phase? We identified T1 and it's being active, not committed. T2 committed and completed its work. We decided to undo the T1 transaction and revert back the value of employee 101 to its original value. Redo. We go through the log and we will redo the committed transaction T2, right? So we use a forward pass here and then we redo the work what T2 was trying to do. Done. Now we reach to the fourth phase of Aries, which is called as end of recovery. After completing both undo and redo phases, the database now is perfectly in the consistent state. The salary, which was changed by the transaction 1, has been undone, and the new employee, which was inserted by T2, have been successfully committed. So these are the 4 things that are taken care by Aries algorithm, one after the other. It first of all identifies and analyzes the transactions which were active, not completed, not committed, and the crash happens, so it will undo them. It will analyze all those transactions that have been completed successfully before the recovery, so it will redo them. After doing these two things, it makes sure that the database is in the consistent state. Okay. So this is about how the analysis phase, redo and undo works. Or here we have a simple image, picture talking about it. The algorithm stands for algorithm for recovery, A for algorithm, R for recovery, and isolation and exploiting semantics. Okay, so the LSN, we will talk shortly about the LSNs. So now wherever there is a system crash, it will analyze to make sure what are the transactions that were committed, which were in the transaction table, and what were the transactions which were still in the dirty table page. We will talk about dirty table page shortly, which only means that these transactions were in the middle of its execution. They were active, but they did not complete and commit. So those entries are in the dirty page table. The transactions that have completed and committed are in the transaction table. So it will analyze and it will redo all the committed transactions. It will go forward. This is called as forward pass. And it will undo all the transactions by moving backward for all other transactions that were not committed, or you can say which were found in the dirty page. Okay, so we talk about the same things here in the 3 steps. A quick recap, analysis phase is to identify the dirty pages in the buffer and the set of transactions that are active at the time of crash. The appropriate point in the log where redo is to start is also determined in the analysis phase. Necessary redo operations are applied for all the transactions that were found in the transaction table. Undo operation is to scan backward, and the operations of transactions that are active at the time of crash and they were still in the dirty pages are undone in the reverse order. Now let us talk about what is log, how does it help us, and what is log sequence number. A log record is written for every data update, for every transactions that have committed, for every transaction that have aborted, for every undo, and when we reach the transaction end. So a log written is created for all these 5 possibilities. It means wherever you are updating a data item, a log is created for it. And whenever you created a log, you will get a log ID, log sequence number, which is nothing but a log sequence number, and the details about the data update. It's before images and after images and so on. Whenever a transaction commits, it gets a log entry, and we know how to write the transaction log. You remember we have T1, it is used for committing the transaction and save. Then we have transaction abort and undo and transaction end. In the case of undo, wherever you are going to perform an undo, a log is created. However, a compensating log record is written. Okay, so what kind of a log is created for undo? A compensating log record is written. Okay, is created. It's not a log. It means like, there are 5 places where a log is going to be created, but especially for undo type of actions, a special log record called as compensating log record is created. Now, let us understand what is a unique log sequence number. A unique log sequence number is associated with every log record. LSN increases monotonically. It means, it either keeps on increasing to tell that what are the different logs, IDs, and then, or it continuously decreases. It's like, for example, if you have academic ID, the new student who comes gets increasing academic ID, right? Or if it means that academic IDs are increasing. So either increasing or decreasing is called as monotonically. It continuously increases or continuously decreases to maintain the uniqueness. So LSN increases monotonically and indicates, what does it indicate? It indicates the disk address of the log record, of each log record that is associated with it. So every log record, okay, wherever it is saved in the disk record is, referred by the LSN in an increasing fashion. In addition, each data page is going to store the LSN of the LSN of the latest log record corresponding to the change for that page. So whenever there is a page, change action or a page update action, what is it going to do? It is going to make the latest log record also getting associated with the LSN. Okay. A log record is going to store 3 pieces of information inside it. The previous LSN of that particular transaction. Okay, what action did T1 made? That LSN, that log sequence number for it, the transaction ID, and the type of log record. Okay, what are the different types of log records? Update, transaction, commit, abort, undo, and end. Okay. Now, let us see how what a log record store has inside it. We just said it is going to have a previous LSN, it is going to have transaction ID, it is going to have type of the log record. Okay, so previous LSN, why do we need it? It links the log because we need to link the log record for each transaction, right? So it's like a back pointer to the previous record for the same transaction. For example, if the transaction T1 is trying to deduct 500 riyals from account A and make it deposit into account B, so we need to have these two actions connected with each other, right? We need to make a list of it so that if one is undone, the other also have to be undone, right? So we need to have this link between them. So previous LSN is providing that link to us. The transaction ID to just uniquely identify which transaction we are working on, and the type of log record. Okay, for a write operation, if whenever there is a write operation, extra information is also logged. What is that? The page ID on which the write operation is being performed, that entry is also included. So page ID for the page that includes the item is also recorded. Length of the updated item is also recorded. Its offset means starting from the beginning of the page. Starting address of the beginning of the page is also recorded. Its before image is recorded. If after image is also recorded. So these 5 informations are also written or also logged whenever you have a write operation. Okay, now let's proceed further. Now let us understand what is a transaction table and what is a dirty page table. Okay, now we know that Aries makes uses of transaction table and dirty page table to make sure that to make sure that it performs this analysis phase of identifying the transactions that have been committed and the identification of transactions that were active and that were not committed. So it looks at the dirty page to identify the transactions that were active, but they were not updated or they were not committed. Transaction table will have all those transactions that ran to the completion and they were also committed successfully. So for efficient recovery, following tables are stored in the log during the checkpointing. Now we have a new term here, checkpointing. So in order to analyze which transactions have been executed, which transaction did not commit, there is a checkpoint being used. So checkpoint tells that a place or the time with respect to the database where it was working properly. So a checkpoint can occur before the system crash. So transaction table contains an entry for each active transaction with information such as transaction ID, transaction status, and LSN of the most recent log record for the transaction. Okay, so in the transaction table, we are going to have the entries of all the transactions, okay, and the information such as its ID and its status committed like that, okay, and LSN. Now, dirty page, once the changes are made to the page, okay, now it's like you have a buffer and then you are making the changes into the buffer, but you did not write these changes to the disk. So those kind of writings are written inside the dirty page table. Once the changes are made to the page, the DBMS mark the page as dirty page because it is in the buffer or cache to indicate that it contains only unsaved modifications, because when we save, the data items from the buffer or the cache will be written into the disk. So it is like one step before writing to the disk. So that page is marked as dirty, which means that there is a need to commit it. So this means that the page is in the memory. The page in the memory is no longer sync with the page on the disk. This is what we mean to say. It means that whatever pages we have in the memory are not sync with the disk. Okay, once you write into the disk, then it is said as the transaction being committed, the changes being modified into the disk. So so it will be no dirty page anymore. Okay, for example, like you wrote your assignment on a paper, but you did not submit it to the teacher, so that page is not a graded page, rather it is a dirty page. So once you submit it to the teacher, she will mark it, so now it is a corrected page. So similarly, whenever there is a change in the memory or in the cache memory, okay, and the transaction is active, okay, it means the DBMS is going to mark it as what? As a dirty page. Okay, once these changes are written to the disk, then it becomes committed, right? So with the status committed, it will be transferred into the transaction table. Now let us understand more about checkpointing. A checkpointing helps you to do the following things. Okay, right? It writes a begin checkpoint record in the log. It can also write an end checkpoint record in the log. With this record, the content of the transaction table and the dirty page tables are appended to the end of the log. Now, checkpointing also writes the LSN of the begin checkpoint record to a special file. So wherever you have to write about the LSN of the begin checkpoint, you are writing it into a special file. This special file is accessed during the recovery to locate the last checkpoint information. So it's like, whenever there is the checkpointing has its begin and end. And the LSN is associated with this checkpoint, and it is written in a special page onto the disk. So wherever there is a recovery process needed, you go to the checkpoint and you start to recover from that place, or you start to undo from that place. Okay, so this is like a checkpoint. For example, if you have just remember when you were kids and your notes book needs to be corrected from the teacher, so she will correct, for example, chapter 1, and she marked the chapter 1. Now you start working on chapter 2. Okay, so now when you submit this book to the teacher, she knows that she finished chapter 1 because she sees her signature there. So that is like the end of the checkpoint. Begin of the checkpoint was the chapter 1, and the end of the checkpoint here was chapter 1 ending, where she put the grade for you and she made a signature. How is it helping her? The next time when she have to correct the pages and grade your notes, she's going to start from the last checkpoint, not from the previous checkpoint. Are you understanding? So place where the checkpoint ended, she has to start from there. To reduce, this is used to reduce the cost of checkpoint. Okay, to reduce the cost of checkpointing and allow the system to continue to execute transaction, Aries uses a fuzzy checkpointing technique. Okay, so it's like, you have checkpointed from page 1 to page 5. Okay, then if some recovery has to be done, it means it will continue from this checkpoint after 5. Okay, now, a quick recap of understanding how the analysis is done using the checkpoints. The following steps are performed for recovery. In analysis phase, we start at the begin checkpoint record and proceed up till the end checkpoint record. Okay, so analysis is done like this. For example, if we have pages 1 to 5, one is begin checkpoint, 5 is end checkpoint. Analysis will go through analysis of all these pages from 1 to 5. It will access transaction table and the dirty page table that are appended to the end of the log. So it will go and check the transaction table and the dirty page table. Note that during this phase, some other log records may be written to the log and the transaction table may get modified. The analysis phase compiles a set of redo, what things it has to redo, what things it has to undo to be performed, and then it ends. Okay, so only one sentence is being extra here. That is, in analysis phase, we are going to analyze the checkpoint from its beginning of the checkpoint and ending to its checkpoint. And we are going to see the entries in the transaction table and the dirty page table, which are appended to the end of it. Okay, and then the ARIS decides what transactions to redo and what to undo based on the committed status of the transaction. Redo phase starts from the point in the log up to where all the dirty pages have been written and move forward to the end of the log. Okay, any changes that appear in the dirty page is redone. Undo, what does it do? How does it undo? Starts from the end of the log and proceeds backward. So undo is going back, redo is going forward. So it will move backward while performing appropriate undo. For each undo, it writes a compensating log in the log record. So this is how the recovery is performed. So redo is done. It starts from the point where all the dirty pages have been written to the disk. So yeah, anything that have been transferred from the dirty page, from which is nothing but your memory or the buffer, flushed into the disk, means they got committed, right? So redo is done for every such case. Undo is done for the cases where the data item have not been written to the disk. Okay, and in redo we move forward and in undo we go backward. Now let us see how the recovery is performed in multi-database system. Now let us assume a situation wherein you have a distributed data system where one node may be running relational database system under Unix. Okay, another may be running object-oriented system under Windows. So, here you have two different devices, two different types of databases, two different operating system. Everything is different and you have multiple such systems. A transaction may run. Now, if you, assume that a big transaction is running in a distributed fashion in multiple nodes. In the case of in the case of transaction failure, what should happen? It's quite complicating, right? It is not, first of all, in the single place. It is not in the single place. It is distributed. The transaction is longer. It is distributed, right? And moreover the parts of the transactions are being run by different computers, right, in different places. So special care has to be taken here. In this execution scenario, the transaction commits only when all these multiple nodes agree to commit. Okay, so all these, multiple systems running multiple types of operating system, running different types of relational databases or object-oriented databases, they all have to agree that they all are ready to commit. Then only the complete transaction will commit. So the commit, they agree that they are committing individually the part of the transaction they are executing. So after all of them agree to save their transactions individually, then only a big then only the overall transaction is committed. This commit scheme is referred to as two-phase because one phase is the commit individual and one phase is the complete commit, right? So that is why it is called as two-phase commit, 2PC. Okay. If any one of these nodes fail or cannot commit the part of the transaction, then the transaction is aborted. So we cancel the transaction. Each node recovers the transaction under its own recovery protocol. So whenever the transaction is aborted, it means the transaction has to be recovered. So how is it done? Now each system will decide whatever protocol they are using to recover. It is up to them. Okay, so with this we have completed the chapter. We talk about the types of failure that wherein the database recovery is needed. We talk about the transaction log. We talk about the different types of update that includes immediate update, force update, and many shadow updates and all those delay update, lazy. So many we have discussed data caching techniques. We saw transaction undo and roll back and roll forward. We saw what is checkpointing. We talk about recovery schemes using ARIS recovery scheme and recovery in multi-base database system. That's it for this chapter.